What is LiDAR?
How does LiDAR really work? The system sends out pulses of light energy which travel through the atmosphere, hit an object, like for example, buildings, facades, trees or surface of the ground. They are reflected, returned back and detected by the scanner. The scanner sends out thousands of pulses per second, and the resulting data are the so-called point clouds, very dense, containing 3D points with three-dimensional coordinates in space.
What techniques are used?
We can use the LiDAR principle in several different ways to obtain high-resolution spatial information. Maybe the most obvious one is the so-called terrestrial laser scanning. Thereby, a static scanner is rotating around a vertical and a horizontal axis in order to scan all the surrounding objects. Such objects can be, for example, outdoors, like man-made objects, or also natural objects, but this method is also well suited to be used inside rooms or also inside caves, for example. Depending on the individual settings, resolutions up to 1 mm can be achieved with this method. If we want to cover large areas, the scanner has to be mounted on some moving platform, like an aeroplane. This method is called airborne laser scanning. The aeroplane is flying several hundred meters high, while the scanner at the same time is scanning the ground below. Even from great heights, at least tens of points per square meter can be measured. With UAVs, so-called drones, even more than 1,000 points per square meter are possible.
How can we obtain the Earth's surface deformations from LiDAR?
In the EU project GATHERS, we want to determine deformations with airborne laser scanning. And the cause for these deformations can be human building activities or geomorphic processes, for example landslides. And in order to do this with airborne laser scanning, we need multiple airborne laser scanning campaigns taken at different times, 2 or 3 maybe. And the difference in the surface models that we get from the airborne laser scanning data can measure these deformations. And the key to that, and that's the special contribution of TU Wien in the project GATHERS, is very precise calibration and georeferencing of those airborne laser scanning data.